So are there any questions at this point? I might take a few more minutes and show you how to use the limit switch. Because I might be able to get that done in another 5 or 10 minutes.
Yeah.
Because it's similar. And it's kind of a good starting point for what.
Use the limit switch as your button. So when it hits, it stops blowing.
Okay, I can do that. Want me to do that? That's way better than the example we had.
But you're not capable of running the motor and moving the servo at the same time, so you might be in trouble.
Well, yeah, you're right. Okay, well, let's just go. Okay, so I'll just say that's a great. Okay, that was intentional. Okay, so I shut it off. So let's make this change. We want to add the limit switch. We want to have the limit switch kill the be a break instead of my button 1. Perfect. So where do I start? Someone here. I'll put you to work. I'll drive, but you tell me what to do. Where do I start? Begin. Go to the block diagram. Sorry, go to block diagram. Here's another shortcut for you to write down. Control E toggles between the front panel and the block diagram. I was doing that and I always forget to mention it. Okay, so what do I need to do now?
Work with me, people.
No, you got this. WPI.
WPI.
Yeah.
And then we're getting a limit switch, right? Where's limit switches?
Keep going. Keep going.
Sensors.
Sensors?
Is it I/O? I think it's I/O.
Yeah, digital data. Go with that, yeah.
Digital input.
Digital input, over. Yeah. Digital input.
Yeah.
Okay, now what?
Limit switch. Open.
And
Close. Just kidding.
And
Register.
name.
okay, now what?
No, we can find out what bold is. DIO channel. What channel?
DIO channel.
1.
All right. Constant. Constant.
Great.
Constant.
DIO1.
DIO1.
Okay, now what?
I'm feeling good.
You gotta connect the two.
Connect the two. Okay, now what?
Constant.
Would be 8.
Constant.
Hey!
Charlie.
Okay.
Charlie.
Nice.
Charlie.
Charlie.
Okay,
So
now
that's
what?
our limit switch.
Hook it in the air. Hook it in the air. We're ready.
Bring it down and hook it up.
I think we have a ringer in the audience. Okay, now what? I closed that. What's next?
Telly up.
Now what?
Control E.
Control E. Excellent. Now what?
We're going to change the input from button 1. Oh, we have to.
Well, hey, I'm at your disposal. You tell me what to do.
Well, it's button 1, but button 1 hasn't been brought in. Or is it automatically on the
Explain to us what's
Yeah.
What we want to do is we want to read our limit switch and use it instead of button 1.
We need the right click for sure.
Okay, and I'll give you a hint. Look at what did we have to do with the servo in order to write the servo? So we need to have a copy of all of our stuff over here somewhere.
Yeah.
So we need to do the registry get.
Oh.
Important. Registry get.
Oh.
Because otherwise, how does it know we want to read from Charlie? Right? So we're going to connect this up. Now what?
Name it.
Right. Remember, whenever you're lost, Control H and look for bold stuff.
Reference
Reference name. So right click. Create constant.
Charlie.
Oh,
this is where you use spelling.
Charlie.
Use capital.
I-E.
That's right. Did I do it as I-E? The first two I was farting around. I didn't realize it. Okay. All right. So now we've got our reference. What do we need to do now? Hook it up to what? Okay. To this box?
No.
Okay, now
We have to get it.
we have to get. Thank you. We have to actually get the value. All we've got so far is the reference. This is just saying, hey, I'm talking to Charlie.
Put it right underneath the joystick.
right underneath the joystick yet. No problem. And then what? Connect that up to there. Okay. Excellent. Now what?
Control H, we're stuck.
Well, what do we want to do? We want to replace this button. We don't want to use this button
Delete
anymore.
that button. Delete it.
It's gone.
Connect that to the wires.
Okay, and so just here's a little aside note here. You see how we've got all these broken wires? It's because we deleted something from the middle. We've still got to get rid of those wires, otherwise it won't be happening. So I'll double click and then delete the bad wire. Okay? And so then the value, and notice the color of the word value and the color of the wire? Green. Okay?
How do we know whether the limit switch gives a 0 or a 1?
Excellent question. In this case, because I was playing with it this afternoon, I know that when it is pressed, it gives a false. And when it is not pressed, it gives a true. So right now, it's false. Right now, it's true. So is this the logic we want?
Wait a minute, false when it's pressed. False turns off the motor.
Yes, false when it's pressed.
Switch.
Actually, false gives the motor power. The true.
Right. So we actually want to flip these cases. And there's a nice shortcut. If we right-click, we can make the current case, so we're on the true case. We right-click, make this case false, which flips them around. Okay? So now let's just revisit. Right now, when it's up, the value is true, which means, if I can find my mouse, so right now, the motor is on. Right now, it's false, which means 0.
Okay.
Okay? So, let's run it.
Can I ask you a question?
Yes?
Why don't you tie the joystick to the outside of the box?
Why don't you?
Yeah. See the joystick when you pull in the lister?
There's no good reason for that.
We should have done it for.
It's because of the way we stripped the default code out to make it a little simpler.
It still works.
It's Patrick's fault.
No, Patrick.
It really doesn't matter in this case. There is a slightly more complicated reason because we don't want to do it in the init or in the stop cases, but I don't want to confuse anything. It could be outside just as well. In fact, if it were me, they would all be in the same place, so for consistency. So let's run. See what happens here.
Is there a window or something where you can check live sensors, like check them live, so you can press it and you'll see if they're 1 or 0 or true or false on the screen? Or anything like that?
I think you can do that as part of the driver station, but I think that's what that IO screen is for.
Okay.
I know it's coming.
Let's try it. Did I miss something? You're looking like you're expecting a mistake.
This is where the Easter egg pops up.
So right now you won't be able to drive, right? As soon as it comes on.
That's correct.
It may not be
I'm not
pushed all
sure.
the
It may
way
not
up.
actually be. You may have to have a force on it. I can't quite tell. All right, the moment of truth. You gotta wait for the robot code to go green.
Here it comes.
That's pretty fun. So, I just don't want to see any pictures of anyone's face under there.
You have to put it on.
I think we do. It does go pretty darn fast.
It goes way too fast, actually.
So go fast and then quickly jam the servo onto the ground.
I think,
Looks like you're on eggs.
The next
pretty much like we're driving outside was like on the way here. Okay, so we're awful close to our 5:30 point. I think this is a great place to stop. My goal is to give you a flavor of what it's like programming in LabVIEW. Basically, you could have a robot which is 10 times as complicated, and you would just have to do all this 10 times. You just keep making copies of stuff, giving it names, and making your code talk to those things. So, for those of you who do have some experience programming for FRC before, I'll leave it to you to offer judgment as to whether you think it's easier or harder. I'm certainly a big fan of programming with LabVIEW. I've been doing it for the last 16 years of my career. All I do in my job is program LabVIEW. It's all I've done for a long time. So, at that point, let's just open it up for any questions, comments. Anybody got anything they'd like to ask? We didn't quite get to the autonomous, but programming autonomous is basically exactly the same as this. Yep.
In the teleop mode, the watchdog only looks like it gets fed once.
That's a great question. And basically, let me try and give a short answer to it. The way the watchdog is handled is every time you give a command to the motor, it actually does. Oh, wait a minute. There we go. Before I make sure I'm not saying something stupid. Oh, the watchdog is being fed every time this code runs. Right? This code is running over and over and over and over again because it's in a loop. The loop isn't in teleop, the loop is in robot main. So it is getting hit a lot. I was about to give a somewhat unusual answer for, yeah, anyways.
Does the watchdog just report back what is being input or output?
The watchdog is there in case you make a bad mistake in your code and you crash the robot and you crash the software so that it shuts itself down. Basically what happens is the reason it's called watchdog, and it's a little politically incorrect, they used to be called kicking the watchdog, like you would kick the dog awake. Right? So the idea here is that if the dog ever falls asleep, that's really bad. So you keep hitting the dog so that it wakes up. It's terrible.
That's why we feed it.
That's why we feed it now instead of hitting it. It used to be called hitting, right?
Yeah, it
I was called. So you feed the watchdog so that the watchdog is happy. If the watchdog ever gets, this analogy is stupid. Basically, it shuts off the robot if you don't feed the watchdog. So if you did something silly here that took 10 seconds to run, your teleop is no longer responding because it's not reading the joystick, it's not doing all this other stuff. Because we're trying to, I don't know how accurate I am. But, so if you don't feed that watchdog fast enough, the robot will actually shut off. But the next time you give it a command, it will come back to life. That's basically what it's for. It's a safety. Any other questions about anything?
When you say finish, what?
Yeah, if we were good little programmers, we would have been actually adding to the finish every time. All the finish does is the registry read and then the close. And we were a little lazy, which is why we didn't add the limit switch and the servo, which we should have done. So the other thing I want to say is I mentioned one of our websites is FRC Mastery. If you write anything else down, write down frcmastery.com.
It's good, I've been there.
There's a whole bunch of videos. Actually, almost everything that we've talked about, maybe in a slightly different order, is up there. There's about 10 hours of stuff. It's a little, I'll be honest with you, we're trying to make it a series of shorter segments, so it's a little easier to follow. But once you get going, if you need to learn how to do something specific, I think you're going to find there's a lot of stuff there that will be very easy. Okay, I'm just going to shut this off before it. Yeah, there we go. Yeah, so frcmastery.com. Take a look under Try Me. I think there's a whole bunch of FRC LabVIEW related videos. Any other questions about anything? Great. Well, thank you for coming. 5:30 on the dot.